This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 45. Hope everybody's doing well. We got a great presentation today from David Zaff, the Science and Operations Officer at Buffalo, New York Weather Forecast Office. The title of the presentation is Morphed Integrated Microwave Imagery at SIMS Total Precipitable Water MIMIC-TPW for Winter Applications. Our facilitator is Dave Riddell, the SU at the New York Weather Forecast Office. Just a few reminders before we get started that we are recording the session. As you heard, there will be an opportunity for Q&A after the presentation, so please feel free to enter your questions there, or at least indicate that you have a question and we can pass the audio to you. We will field them in the order they are asked. We are always looking for future presenters, so if you have an application that you'd like to share with your colleagues in the field, or if you're a scientist that you're looking to expand your outreach to the field, please get in touch with us. And as always, the training team, Brian Mata in the Office of the Chief Learning Officer, can take your information and questions regarding training materials that may be unavailable or you may be unaware of. Thanks to the TowerS team, particularly Kashad Bowman, the Office of the Chief Learning Officer, GOZAR, and JPSS program for their support of the Satellite Book Club, all that work that goes on behind the scenes. And thanks to all of you for being with us today. Another good set of over 60 attendees. Without further ado, I'd like to introduce David Zaff, who has a bachelor's from the University of Massachusetts at Amherst in physics and a master's from the University of Arizona in atmospheric science. He worked for the NWS offices in Oregon, Utah, and New York. He's worked as the Science and Operations Officer at Buffalo since 2005, and he likes to keep it simple. His Twitter bio has one word, snow, so naturally his talk's going to focus on that topic. So, Dave, take it away.
Great. Thank you very much, Jordan. And thank you, Kashad, in advance for driving the slides for me. We tried this out a day or so ago, and I think we'll have a better presentation and a smoother set of animations with Kashad leading the slides for me. So go ahead and go to the next slide, Kashad. So as mentioned, I'll be talking about this product called MIMIC-TPW. I'll also talk about some other products that are related to it toward the end of this presentation. What I want to focus on are two minor snow events that occurred over western New York this past winter. One was on the 22nd of February and one was the following day on the 23rd. But I want to emphasize these were really minor events, and that's actually what caught my attention. Just as a comparison between what you might be able to do with looking at precipitable water, in this case MIMIC-TPW. In general, the overall the idea behind this presentation is to show that precipitable water in general could be useful for forecasters even during the winter. Next slide, please. Before I get started, Buffalo, of course, is known for its lake effect event. So this event, that's my backyard that occurred a day before the event I'm going to talk about. We got a good 24 inches near my house out of this. As you can see on the gradient with the observed snowfall on the left, the lake effect, of course, as you're familiar with, we can get some crazy gradients with nothing in Buffalo and 2 to 3 feet in other locations. But that's not what I'm going to talk about. I'm going to talk about just the little stuff. So if you can go to the next slide. So what I have here is a set of graphics that show essentially a model forecast, our forecast, and the observations. So on the upper left, I'm just getting your attention on where we're forecasting for. You can see New England on the far right of that image. You can see a focus there. You can see most of New York here over to the southwest portion of that graphic, or far left part of that graphic is Lake Erie, Lake Ontario, and then within the box, I'm just highlighting where Buffalo is roughly. The graphic itself is showing a 24-hour max value ensemble from the HREF. So sort of, I'm just equating this to the sort of the worst case scenario from a modeling standpoint. What's the highest snow we could possibly get out of this? On the lower left graphic, you can see what we produced, at least from a public standpoint, from a IDSS and out to social media. For the Buffalo area, we are forecasting basically a dusting of snow. And then as you get towards some of the higher terrain to the south of the Buffalo metro area, 1 to 2, nothing really extensive or impressive. The upper right has a table, pretty much what I just showed you, with href of 2 to 4 inches. We were going under that a little bit with trace to 2. And then the result from a CocoRa's map, you can see that we were a little under forecast for this event. Not by much, but just a little bit. Anywhere from 1 inch to 5 inches, depending on the location. If you can go to the next slide, please. The problem with the slight under forecast was it occurred right during rush hour. And you can see just a snapshot of various things from Twitter. It was a mess. And it really wasn't a lot of snow. If you can go to the next slide, please. So hopefully this will loop for you. I think I'm seeing the same loop that you're seeing. This is roughly an animation from 0Z on the 21st of February this past year through 8Z on the 22nd. And the intent here is to show you the synoptic nature of this. You can see a nice subtropical jet coming up, typical comma cloud feature. The surface low would be somewhere over Ohio toward the end of this loop. And I'm stopping it at 8Z to give you an idea of where the forecast process might be. 8Z in Eastern Time, Standard Time would be, I think, 3 a.m. So at this point, the forecasters on the midnight shift would be putting together the last touches to the forecast and thinking about, is there anything else that they want to do to make some slight modifications before they send out the forecast for the following day, for the upcoming morning. And your eyes from this water vapor image, it's the mid-level channel 9 water vapor image, are clearly drawn to the synoptic feature itself in the subtropical jet. If you go to the next slide, you'll see from a precipitable water standpoint, or this product called MIMIC, and I'll talk about what MIMIC is in a minute, you see a whole different pattern that emerges. And your eyes, rather than being focused over the Great Lakes and upper Midwest areas, your eyes are actually drawn toward the Gulf, which isn't where you would typically expect, well, I guess you would expect it, but we don't typically look at it very much. So you can see this surge coming up from the Gulf into the lower Mississippi River area, and then moving into the Appalachians. And it's pretty subtle, and it ends at 8Z again. Toward that last image, you can start to see it focus a little bit more closely toward the Ohio River Valley. Next slide, please. All right, so this image is a little bit later. It's actually toward 12Z. And so you can see this is about where we start to have our higher snow rates occurring. But I'll get into that in a minute. I want to describe what we're looking at. So this is MIMIC-TPW. It is the Morphed Integrated Microwave Imagery at SIMS dash total precipitable water, or MIMIC-TPW. A little bit of background. It's generated from a series of polar orbiters that are orbiting around the Earth. You get about 2 passes per day per satellite. If you add all that up with maybe, I think it's 7 satellites, there isn't enough data to produce an hourly image. However, if you merge it with GFS winds going both back into the forecast process, essentially before the 0-hour forecast, and then going a little bit past it, maybe 2-3 hours as necessary, you can advect the polar orbiter imagery and create a nice hourly loop. And you know, I put in parentheses here, who wouldn't want an hourly precipitable water loop? It's really nice. I believe this has been around for at least 10 years, or around 10 years. It's designed partly for tropical systems and atmospheric rivers, and instinctively you wouldn't think this would be useful for winter events. But as you'll see from this next slide, I think it does have some value. So if you go to the next slide, please. So here's a loop. It drops off at 12Z where I was, 8Z where I was before. And you can see actually, if you look more closely at this, there's actually two areas where there's moisture merging. You have a easterly flow coming off the Caribbean, going up the Gulf, and then Gulf moisture itself. So there's actually two areas of moisture that are converging and then going up into the Appalachians toward the Ohio River Valley. So if you were stopping this, if this loop were to be ending at 8Z and you were thinking at 3 a.m. and you had to decide, did you want to go toward the higher end of the forecast models or go toward the middle, this might give you some guidance in saying, you know, all other things being considered, assuming all snow, you might want to go toward the higher end of the guidance. Next slide, please. This is a poor straight line graphic, just showing you those two areas of moisture. Obviously, with PowerPoint, it doesn't look as good. If I could curve those arrows a little bit. But you get the idea that there's two surges of moisture going right up into the Ohio Valley. Next slide. Finally, this image goes through 12Z, and you can see that it's pretty subtle, but you can see the tip of that moisture plume going right toward Buffalo, and then you can almost envision it going past Buffalo after this time. So this is right at the point where we were getting our heaviest period of snow. The lower left graphics show the surface map from WPC and an MRMS RALA image showing in this case, snow for the Buffalo metro area. And you can see it's a synoptic system. It has nothing to do with lake effect for this event. Next slide. Now, you know, this isn't a silver bullet for forecasting by any means. It's not like we don't have precipitable water available to us from a forecast perspective. So here's the HREF output, just a mean value from the HREF showing that precipitable water was indeed increasing over us. But we don't typically use precipitable water in our daily winter forecasting. Next slide. So here you can see three different soundings. The first sounding is 12 hours before the event. We were fairly dry, relatively speaking, with a precipitable water of 0.18. And then during the peak of the event, around 12Z on the 22nd, you can see we surged above climatological norms by just enough, up to 0.49, which is a pretty good amount of precipitable water for the middle of winter. And then at the end of the event, we dropped right back down to a normal level of 0.35. So there's a pretty good spike in precipitable water here, and it matches both the modeling and, of course, the observed. Next slide. All right, so that was the first event, and I'm repeating this slide just so we can refamiliarize ourselves with what the original forecast was. Because on the next slide, what I'm going to do is we're going to go from 222 to 223 so you can see the difference. It's going to be the exact same images. We'll have HREF, the forecast from the Buffalo office on the lower left, and we'll have a COCORA's storm summary on the right. So Kashad, if you could go to the next slide, please. So once again, this is just 24 hours later, subsequent forecast and observations. And comparing the two from the HREF, sort of the worst case scenario, it's gone up by a little bit. There's a little bit more of an elevation input here or output here. So I put on the upper right 2 to 4, 4 to 8, depending on locations. If you look on the lower left slide, compared to the previous day, we're forecasting snow amounts that are just slightly higher. We had a trace the first time, and now we've upped our snow amounts for 1 to 2. And then if you look at the result, it was pretty much on target. We didn't have too many things that went awry for this particular case. And by awry, we're only talking a few inches anyway. These are really small, subtle events, particularly for Buffalo standards. I do want to emphasize this case was also synoptic, And I'll show that to you on the upcoming slide. Kashad, if you could go to the next slide, please. So here's a 1.5 day loop, just at hourly time steps for simplicity. And you can see the first system going right across the Buffalo metro area. It's a nice synoptic feature, goes off the East Coast. And then the second system is more of a clipper that's coming from Canada and then going across the upper Great Lakes and eventually the lower Great Lakes, where Lake Erie and Lake Ontario. So it's an entirely different system in terms of makeup. Next slide, please. This is a similar time span from the precipitable water, or the MIMIC-TPW. And again, just like the last time, your eyes are focused on a different set of data, really. The first one has this surge of moisture coming from the Caribbean and a secondary surge from the Gulf of Mexico coming up the Appalachians, then moving off to the east. The second one is almost undefinable. You hardly notice it at all. You can sort of see this very dull change in precipitable water as it comes across the continental air mass. As you would expect, it's a drier air mass. So this would be, again, a situation where you could use this type of guidance to, along with all the other things, and I just sort of threw out some acronyms just for fun: QPF, SLR, DGZ. You can see the description down below. But you could use this in addition to everything else that you would be using for your forecast process to decide whether you wanted to go above or below or keep it on track with what the forecast models are showing you. Next slide, please. And just to match what I had done for the 24 hours prior, the following these images show the soundings 12 hours before, during, and after the event. And you can see there's a much more muted response in terms of precipitable water. There is a little bit of a increase from 0.35 to 0.42 and then 0.32, but it's much more nuanced, much more of a subtle spike. Next slide. Okay, this one's pretty complicated. There's a lot going on here. But the point of this slide is to show that there are other options for looking at a satellite-derived precipitable water product. So on the first row, you can see a Sierra product called the ALPW, or Advective Layer Precipitable Water Product. And this was something that Sheldon Kay down at the bottom of the slide, who's worked for, I believe, for both Sierra and Noah Nesdis. He put this together for me. So the advantage to looking at this is you can look at it and break it down from a layered standpoint. You could look at the surface to 850, 850 to 700, 700 to 500, et cetera, et cetera. The column second from the right shows a Noah Nesdis blended precipitable water product, total precipitable water product. So that's something I believe all AWIPS workstations across the National Weather Service have. And then here's the two on the right column, the two MIMIC products that I was demonstrating earlier on this presentation. The bottom row is just for the second event, so you can see the differences between them. So once again, the point of this slide is to show that there are different ways and ideas on how to represent this particular conundrum that we have in terms of showing precipitable water from a combination of polar orbiters and from a modeling standpoint. Next slide, please. I believe this is the final slide, and this is just kind of showing where we're getting the Sierra, where the Sierra product is derived from. Same basic idea. It's using, in this case, yes, we're still using the microwave retrievals from the polar orbiters, and you're also using GFS model winds, and then advecting that precipitable water from the satellites as needed to get a similar product with MIMIC-TPW. Next slide. So as a summary, I think we could use precipitable water quite a bit more than we're doing in the wintertime. MIMIC TPW or ALPW or the blended product that we have in AWIPS, they're all useful for identifying atmospheric rivers in conjunction with winter synoptic systems. I know Sheldon, nearly every time we have a major winter weather event, he's posting stuff from the ALPW or talking about it. So it does have a lot of value. And just as a quick, sort of an obvious caveat, every situation, of course, is going to be unique. This is by far from any type of silver bullet. It's just one extra feature that I think we tend to look at less in the wintertime than in the summer. So the point of the story here is precipitable water does have value in the winter. I believe that is it. And so I'll turn it back over to Kashad and Jordan for questions, or Dave Riddell. I guess it's Dave Riddell doing the questioning.
Hey, Dave. Yeah, that's why I'm here. Very good talk. Enjoyed this. A couple of things before we move on. Please hang out for a couple of minutes, folks, for some discussion. You'll notice in a few minutes in your GoToMeeting window that Kashad is going to actually post a feedback form if you have a chance to take that post-event to share a little feedback with the TowerS group on this seminar series. And a reminder, before we move into some of the questions for Dave, a reminder that a week from today, on the 22nd, same bat time, a different bat channel, Curtis Seaman from CIRA is going to talk about Veer Snowmelt RGB. And so look out for the announcements for that for next week. And again, just as another reminder, the TowerS folks, Lee and Kashad and company, for the folks out there at the WFOs, if you have questions about configuration of satellite products and information, make sure to email Lee or Kashad. And of course, you can also find them in NWS chat in the TowerS room as well. All right, with that, if you folks have questions, and folks are already doing this, I think that's good. Go ahead and type those into the chat room. I think that'll be a little easier, and I'm just going to go right down the line. Dave, first question is from Bill Soberg from the JPSS program. Did you have a chance to look at new caps during or after the event?
No, we did not get a chance to use new caps data. If there is an archive of these events, it'd be great to take a look at it and see how it matches up.
Okay, I'm going to throw a question in here, Dave. Given I grew up not far from the edge of your CWA, related to lake effect snow, and I certainly don't envy the forecast challenges that you all have up there with that phenomenon. And you mentioned this in your talk, the layer precipitable water. For lake effect events, have you guys taken a look at the surface to 850 or 850 to 700 before those events, and have you noticed those as being informative and as part of the forecast process at all?
I cannot answer that question. First of all, I do want to clarify that this talk wasn't really focused on lake effect at all. As far as the advected layer products, which I believe you're referring to, we haven't been using that operationally as of yet. So I really can't say for certain whether or not that would be useful for lake effect events.
Okay. Back to the chat. Question from Tony Wimmers, which I think you answered. Were your two cases lake effect snow or not lake effect? And is that what caught you by surprise or not?
They were entirely synoptic. There was no lake effect on either cases. There might have been a little bit toward the end of the second event, but I mean, again, they were minor snow events overall with just a few inches. So in general, they were both synoptic.
Okay. Bill Soberg said, Dave, send him an email about the new caps archive, and he can make that happen. Ed Townsend has a question here as well. At the time of the event or during the forecast process, were those the products that your folks looked at I guess specifically, or was this more of an after, and I'm paraphrasing here a little, or was this an after the event review?
This is definitely an after the event review.
Okay. One other question, that I had, and again, if folks out there do have additional questions, please stick them into the chat. Other than winter weather, and maybe you sort of already answered this question, Dave. Other than winter weather, have you used the MIMIC-TPW for other types of events, warm season kinds of things, or anything else? Even in a retro perspective, I guess.
Now, so I became aware of the MIMIC-TPW probably in 2019 during a satellite meeting out in, I think it was Kansas City. So I've been looking at it from a subjective point of view, and with help from various posts from Sims, of course, when they reference it, or when I see stuff from blanking out his name, Sheldon. It all matches up, and you tend to see things, particularly after the fact, looking at it from a hindsight point of view. It's a great match usually, but we're still in the process operationally starting to use these types of products. I've been mentioning it to our staff several times over the past winter. We'll see where it goes in the summer, but it's still an evolving observational learning process for us.
No, it is for us too. And this is, summertime, warm season. Our office certainly makes use of the blended TPW. Wintertime, hadn't thought about it as much. And I think this is in the sense of kind of revisiting that now, I think has been sort of eye-opening. Let's see, Darren Van Cleve, our friend from Salt Lake here. So this is his comment, and I guess a question, Dave. The thought is, and somebody put another talk in. This is from Darren. So the thought process here is that NWP was not properly catching on to the moisture content. And Darren says, I guess I would hope it would ingest those observations and thus not require the forecast edits, and perhaps just leaning your forecasters towards the higher end of the guidance probabilities.
Darren, I didn't think of it that way. I was thinking of it more as where we can make improvements to our own forecast, basically using the observational data to provide a better forecast product. It's possible. I'm not a modeler, so I wouldn't be able to say that was catching on to moisture content or not. The href example that I put in there seemed to indicate that the model had a good handle on it.
Okay, another comment, I guess Mark from Marquette. Dave, great talk. Great examples on using different tools to tease out the PW signals for winter weather. He doesn't have a specific question, but he wanted you to know that they're looking at atmospheric river events and how they influence winter precip at Marquette using a historical event database, and we'll connect with you afterwards if you're interested. Hoping the work will eventually help with forecasting snow mounts and SLRs and that sort of thing. So thank you, Mark, for that. Again, one more call here for any additional questions for Dave. I'll ask the final question that I have. Let's see. This was more of a and I guess I know the answer to this based on what you've said, Dave, but I'll ask it anyway. We as an office don't typically use don't typically use satellite information in DSS very much, if at all, other than maybe for some tropical systems. But would this maybe be a case, particularly if you're looking at an uncertain event, whether it's lake effect or something else, where maybe you're starting to see a signal within some of this imagery that can maybe better help or potentially help communicate here comes the moisture surge. The uncertainty in the forecast is how far north it makes it or how far into the area it makes it. And therefore, snowfall amounts may depend on some of this. So would this be something you'd ever consider using as part of an IDSS brief? Certainly on social media, but maybe for something a little more formal to try to help communicate some forecast uncertainty?
My short answer would be probably not, at least not for the public. From what I've seen with the public is that they can't differentiate a radar image from a satellite image very easily. And so to add another, it's a great science project, to describe, hey, here's a moisture field, but I don't know if it would be very useful.
Okay. One other thing I was thinking about real quick, one of the lost arts, at least, and I'm guilty of this too, is using satellite data as a diagnostic field for model output. Would this be something where, and maybe this goes to some of what Darren was getting at earlier, utilizing this kind of information to help diagnose model initializations and things of that nature, in terms of whether or not to, an anticipated moisture surge or that sort of thing?
From what I understand is that much of the polar orbiter data is one of the primary sources that are going into the modeling. So I would think this is already embedded within it. But any further conjectures, I don't think I'd be able to go into that much further.
Question from Ross Van Til. And I guess I'll ask you, what's the best spatial resolution of the MIMIC-TPW?
I'm sure that answer is on the internet. I actually don't know the answer to that question.
Okay, and then the follow. Go ahead.
Oh, I was going to say, I think Bill just might have answered that question. It's probably a module.
And then the next follow-up question was, what resolution would you like to see?
The hourly resolution is, better than what we have for most precipitable water products. I'm speaking in terms of temporally right now. We can look at things from an IVT standpoint. Western region is big on that. Obviously, from an observational standpoint, we have the 12-hour balloons. We have new caps to take a look at. So from a temporal standpoint, hourly is great. From a horizontal standpoint, I don't know what would be a good or better resolution. From what I've been looking at, at least from using MIMIC, it looks much better than what I've seen before from an observational standpoint. Could it be better? Yeah, of course. But it looks pretty good right now. Well, one thing I would add is if we could get it into, and I know there are capabilities to do this already, getting it into AWIPS test in a test mode or operational mode, having our ability to modify the color curve, of course, would be critical, because the images I showed right now, you're just barely getting a useful product with a default color curve for the wintertime application.
And it would seem that the zoom in capability is not there either, correct? Those are just static images looking at the kind of Kona scale. Okay. All right. Any other questions? Last chance, I guess, now here to type them in for Dave. We'll give you another couple of seconds here if there's any final questions for Dave. Darren has another follow-up here. Was your office routinely looking at MIMIC last winter, or did they just happen to pull these up during events?
So this is a product I've been looking at and fully advertising to our staff. In this case, in the world of COVID, we've been talking about it through NWS chat. So it's basically slowly increasing awareness. I do want to add, there is a comment there that's from Tony Wimmers saying that the resolution is 0.25 degrees.
Okay. Final call for questions for Dave. Okay, with that, thank you very much, Dave, and we'll turn it back to Jordan Girth.
Okay, thank you, David and Dave, for the presentation and fielding all those questions. And thanks to all of you that are with us today for participating. Just a reminder that next week, Thursday, April 22nd at 12 noon Eastern time, Dr. Curtis Seaman from CIRA will be discussing the VIIRS Snowmelt RGB. So I hope you'll join us for that. And just as a reminder, before you all head out, to please complete the survey. I know a lot of people are asking surveys, but we do really want to make these book clubs the most beneficial use of your time. So please let us know how we can do that. With that, I hope everybody is having a great spring, and we'll see you next week. Take care. Thanks, everybody. All right, that's a wrap.